Ladies and gentlemen, my name is Jae-myoung, professor of Pusan National University. The Ocean Forum this year has many different marine issues, and today we'll talk about marine environment. So the major image or incident that's discussed a lot is the Pacific island that are filled with garbage. As the industrialization advances, we use more plastic, and these plastics enter into the ocean, and someone needs to come up with a solution. And using this platform, I hope that we can discuss various measures to address this issue. And yesterday, I gave a suggestion during the keynote speech, and today I will talk about the technologies that's practical.
My presentation will focus on and is titled as LNG-hydrogen hybrid ship for marine debris solution. The title may sound very bold. This is the table of content of my presentation.
잘 알고
I think you may be very well aware of the challenge of marine debris. Annually, 8.7 million marine waste is being generated, and more marine waste is accumulating in the Pacific Ocean. The biggest issue here is the marine garbage that is not biodegradable. So we need to come up with a fundamental solution to this issue. Otherwise, we will face an overwhelming challenge. The slide shows negative impacts from marine debris. As you can imagine, we may have environmental issues and economic issues. Most of the people are concerned about microplastic. If a wildlife consumes microplastics, some devastating consequences will happen, according to current reports. Indirect consumption of microplastic is over 800 MP, which means it has dire consequences on the humanity and the wildlife. And marine debris also has a negative impact on vessels, and it can also have a consequential impact on the shipping route. We used to use this marine debris disposal process to clean up the waste. Inland, the waste, after being collected, will be buried in landfills before being incinerated. For now, only 5% of the collected waste ocean garbage is recycled. Incineration and sortation, they cannot transform fundamentally the nature of ocean plastics, which means the ocean plastics and ocean garbage have a permanent negative impact on the planet. So as you can see on the slide, many international organizations under the umbrella of UN have been working hard to clean up the oceans. UNEA is one of the leading international organizations, and Global Partnership on Marine Litter, its name says it all, and it is one of the leading organizations working on marine debris as well. Up until now, when we discuss Marine leader challenge. The most frequently used method or solution was collection, and it was land-based. For example, ports and streams have been the places where marine debris and ocean garbage have been collected. And in those places, there was some global systems or technologies in use, including unmanned system. And there have been also projects on this issue. For ocean cleanup, there is this foundation called the same name, Ocean Cleanup. And the wasteland in Pacific Ocean has been a place where we collected the ocean garbage. But as I said on the previous slides, most of these methods have focused on collection rather than disposal. So collection was their primary purpose. Yesterday in the keynote session, I made this suggestion. My suggestion was LNG and hydrogen hybrid ocean cleaning ships. And these ships can be deployed to collect ocean garbage. Ocean garbage and marine litter is facing three challenges, as you can see on the box at the bottom of the slide. The first is volume. When ocean garbage is brought in the form of bulk, let's say you grind it, when you compress it, you can increase storage efficiency by 7 times and by 16 times respectively. So this is how you should do. You should think about how you can efficiently and safely bring the ocean garbage into land. Even if you successfully bring the ocean garbage into land, you have to take the next step as well in land. Collecting and processing ocean garbage is done by trucks or vehicles, not by ships. But if we can use ships in collecting marine debris and marine litter, we can increase the proficiency. So if we can connect all the dots and create the entire chain, we can achieve efficient power management, and we can also build efficient storage facilities. So when the ocean garbage is brought to land, the next thing you need to do is to make it recyclable, and this will save you some costs. So many ship experts have discussed this, and I also consulted them over this solution, and this is a simulation result of my suggestion, and this is the dimension specifications of a ship I'm suggesting. And this can operate from a place in Korea to Pacific Ocean. If you think about the mileage or the route, this ship has the minimum level of specification required. If you mount an eco-friendly engine, if this ship is powered by LNG and hydrogen, we can also achieve saving of energy. As you can see in the simulation, the design is already available. So let me go into details of the specifications and technologies required. The three big technologies are as follows. First, we need eco-friendly propulsion system And hydrogen fuel hasn't been used for a large ship operating international waters. So the second technology is to resource marine waste through recycling, hydrogen fuel cell, LNG, and cryogenic grinding. They can power the ship I showed you in the previous slide. The fuel gas supply system should be in wider use. They can be used for LNG propulsion. And to give you more details, for fuel propulsion, fuel cell and LNG, they are the cleanest fuels. So they are the fuels required for ships facing IMO compliance. So these fuels can contribute to making ships greener and more eco-friendly while meeting the requirements of IMO. And LNG fuel tank can produce hydrogen. In the entire system, the hydrogen can be related to or connected to hydrogen fuel cell, and on board it can provide power for all the systems on board, which means the most efficient power management can be achieved here. The technologies I'm talking about are already commercialized. Cryogenic grinding is the third technology I'm suggesting. In processing marine debris, one of the stumbling blocks is to grind the ocean garbage before bringing it to land in order to increase the efficiency. In order to make it more storageable, make it easier to store it, refrigerants or other materials or ingredients are required. And LNG here can be wasted because after evaporation, and LNG powered ships naturally emits or releases wasted heat. But it can be recycled and reused for this technology. So as long as we can combine and integrate all these technologies, and particles generated in result can be used for recycling. And speakers after me will introduce you cases or examples of recycling of marine waste. Or pavement materials or reinforced concrete. Other examples where this waste can be used after recycling. In other areas we can use this waste is power generation. We used to use fossil fuel to generate electricity, but it caused some concerns. The biggest example is CO2 emission, but if you use the hybrid method, they will save you the CO2 emission challenge and issue. And pellets can be made out of recycled ocean waste. And the technology required for the process is already in place. And if all the process and all the process can come from the LNG-hydrogen hybrid ships. So if a ship is powered by LNG and hydrogen, and if it can be used for ocean garbage, this is what we can achieve. We can pass down cleaner environment to the next generation in the future. That's all I have. Thank you very much.